In graphing each of these problems, I've identified the easy things. A 0 at 1 from the numerator, a vertical asymptote at 2 from the denominator, x over x simplifies to y equals 1. That's my horizontal asymptote as shown. And the last thing that's pretty easy is the y-intercept. When x equals 0, y is a half. So now I have that dot, and I can see very easily, even without that y-intercept, what this must look like. There's no more zeros, so that's how I know that we need to definitely have this portion of the graph. Now when we look at the other function, 0 is the same at 1, vertical asymptote is the same at 2, but now the y-intercept is -1/4 when I plug 0 in for both x and x. So that means that I'm down here at -1/4, which means the only way to have this look is to come through the 0 and then approach my horizontal asymptote. That must mean that the other piece that I can tell is that this is even behavior in the denominator. So this is going to behave like 1 over x squared because of the even power, and so I'm going to have a volcano, and that means this is what I'll look like on the other side of x equals 2. Now if we wanted, we could have just plotted a point like when x equals 3. We'll do that. That's another way to show how this must look. 3 minus 2 over 3 minus 2 squared equals 1 over 1 squared is 1, so I'm going through that dot right there. So it's another way, but you didn't even need to by checking the multiplicity of the factor in the denominator.